Hey guys, I'm back with another video today. This time we're doing it for an Eulers equation that's combined with a variation of parameters question. So an Eulers equation is where you have this x squared, the 2x, and the 2 in front of the y double prime, the y prime, and the y respectively. So to find your characteristic, you're going to use this equation here. So in our case, that works out to be r squared plus r minus 2 is equal to 0. And if you plug it into your calculator, you'll get r values of 1 and negative 2. Now, one thing that's really important here is that we're going to be making this substitution. So I'll show you what that entails in a second. So let's solve for yc. And instead of using x, we're going to use z. So c1 e to the z plus c2 e to the negative 2z. And what we do is we're then going to replace ln z with ln x, and that'll give you something that looks like this. So we're dealing with c1x plus c2x to the negative 2. So we've solved for our yc. Now we need to solve for our yp. So our yp is going to wind up being equal to u1 y1 plus u2 y2. And one thing to note that this yc equation is actually equal to c1 y1 plus c2 y2. So that's from this equation here is how we get our y particular y1 values. Now to solve for u1 and u2, we are going to use our Wronskians. So I'm not going to show you how to do those because I've already made a video on those in the past, but I will tell you that your w is equal to negative 3x to the negative 2. Your w1 is equal to 9x to the negative 3, and your w2 is going to be equal to negative 9. Now I encourage you all to pause the video and actually verify all that for yourself. Make sure you do have practice in solving those determinants, because if you don't, it's obviously going to come back to bite you in the butt. So u prime of 1 is equal to 9x to the negative 3 divided by negative 3x to the negative 2. And that's just w1 by w. So that means that u prime of 1 is equal to 3x to the negative 1. U prime of 2, we solve the same way, w2 by w, and that winds up being equal to 3x squared. Now we'll take the derivative of both of these equations, so u prime of 1 dx is equal to 3 ln x, and u prime 2 dx, the integral of u prime 2 dx is equal to x to the 3. So now that we have those two functions, we're able to solve for our y general, which is nice. So our y general winds up being is yc plus yp, and so that winds up being equal to c1x plus c2x to the negative 2 plus 3x ln x plus x. Now you may be wondering why we've got this x in front of this ln x and why this is x instead of x to the 3. Well, it's because once we solve for u1 and u2, we then plug them into this equation right here. So if you have, u1 is equal to 3 ln x, and u2 is equal to x cubed, what you basically get is, well, what I showed you on this part right here. Anyway, guys, there's a full solution in the comments. Mind you, I didn't write it, but if you have any questions, I'd be happy to answer them. Thank you very much, and I'll see you on the next video.